Welcome to the lesson on types of functions. Here we are going to learn about the basic concepts that need to understand about the types of functions. So we will start with introduction, that is a motivation why we need to learn about the types of functions. Then we will quickly review what is a function. Then we will go into the types of functions. Finally, we will finish with a conclusion, a key points and some applications on that. So let's start. So as I said, we need to know why we have to learn the types of functions. So let us understand it with the help of the real life scenarios. So if you have seen a smart TV remote, you would have seen for increasing the volume or decreasing the volume, there are two ways to be done. First way is using the old traditional method, that is using plus or minus button. Another one is through speech recognition button, that is we can just click the speech recognition button and then we can say the AI to increase or decrease the volume. So for remote we have what? For increasing or decreasing the volume, there are two ways. Just remember this. We are going to connect all these things when we are going to see the definitions of the types of functions. Next is, say we have a two children's name Raju V, that is same name same initial. Then as a teacher to record their data like say marks, I have to avoid the confusion. To avoid the confusion, ID card will be the best way. Why? Because it's going to have a unique roll numbers on that. So understand here we need what? Unique roll numbers to avoid confusion. Next thing, say we have an ICU in the hospital, there are 5 patients or 6 patients. Some patients have stabilized after some time and some patients are not still stabilized. But what we will want? We will want for every patient, even though they are stabilized, but they are inside the ICU. So we need what? Monitors for each one of them. We cannot tell no, they have stabilized so they do not need a monitor. So understand what we want. We want monitor for every patient. Then seating arrangements. When we are conducting exam, we want the children to sit separately to avoid cheating. When we go to the dinner as a family, we want to sit together. So both are seating, but different scenarios is demanding different needs. If you understand, we have different choices according to the problems or situations we come across. These different choices is nothing. We are going to learn. Those are one way we are going or learning about the types of functions, or types of functions are going to solve those problems in a unique way. So let us understand what is function, or quickly we will recap what is a function. Function is nothing. We have two sets x and y, and every element in x should have a unique output. That is, every element should have some output in y, but it cannot have what? Two, or it cannot have the different output. It has to have only one output. In a simpler way to say, every input should have an unique output. We can understand this function as a machine. We put some input x and we get an output y. We can relate it with a juicer machine. Say we have an apple, we put it into the juicer, we get what? Apple juice. We put a mango, we get a mango juice. Can we expect putting a mango we should get a mango as well as apple juice? It's not possible. So it's not a proper definition of a function. A function is every element should have what? Unique output. Okay, so how many ways can we represent a function? 4 ways. Arrow diagram, graph, ordered pace, tables. Arrow diagram. We just list the what? A set A, that is a domain like this. Let us say 1, 2, 3 here is a domain. Then we have a codomain A, B, and then we map it to the functional value. Say 1 has a functional value here A, 2 has a A, 3 has a B. So we use the arrows and we represent them a function. So that is why this is an arrow diagram. Then we can use a tabular column. We can put in x all the domain values in y, that is functional values as a y, and we can write it correspondingly. Ordered pairs. Say you have here 2 comma 2 is connected to 6, so we can write it as an ordered pair 2 comma 6. 5 is connected to 15, or it is mapped to 15, so we are writing it as 5 comma 15, and so on for 10 comma 30. Then we have a powerful tool, graph. What we do, x-axis we take an elements of a domain x and functional values f of x in a y-axis. Then we connect all the mappings. Say minus 2 comma 4, minus 1 comma 1 is plotted, 0 comma 0 is plotted, and we all connect it like this for a graph. Okay, we are going to go into the types of functions now. So we are going to see 5 types of functions: one to one, many to one, into, onto, and bijective. So what is one to one function? A function is called 1 1 if distinct elements of set A have distinct images in set B. So let us say here this ABC is a set A and set B is 1 2 3. What they are telling is a function will be 1 1 if the image sharing is not happening. Image sharing is not happening means, let us go back into the, if you see here this, what is happening here? 2 is also going to A, 1 is also going to A. Here image sharing is happening. What they are telling is this kind of image sharing cannot happen for 1 1 function. In other words, it has to be no image sharing. See, we spoke about Raju example for ID card. There we needed what? Different roll numbers to avoid confusion. So I am assigning here for one Raju 11, another Raju 12. So we can understand why 1 1 function is important. Why? To give an unique output, that is not unique output. For every output there should be what? Unique pre-image. Example here, y is equal to x. Here we have a set as 1, 2, 3 and B set as 1, 2, 3, 4. This we call as a domain. Set A is domain, set B is domain. Set of mapped images is a range. So 1 is going to 1, 2 is going to 2, 3 is going to 3. I am repeating again. Here the domain is 1, 2, 3, that is set A. Codomain is 1, 2, 3, 4. Now range will be what? Mapped images. Here mapped images are 1, 2, 3. So you can see here no one is sharing the images. So this is 1 to 1 function. Many to one function is if two or more elements of set A have same images in set B. That is, image sharing is happening. If you see in this example, B1 is what? A1 and A2 are sharing the same image, B1. Okay. Why do we need many to one function? Do we need it? Yes, we need it. You see this example. Lily, Mike, Rose. Tea, coffee. Lily loves tea. Mike and Rose loves coffee. We cannot say what? Lily also has to go to coffee only. She has to only take coffee only. No. So, here many to one functions come into the role. Not just this. If you remember the remote example I gave you, plus or minus can be your domain set, increasing the volume button. Here, there we can do it through what? Two different ways. Do you remember it? Like we can use for plus or minus, we can use the same speech recognition button. Yes or no? So, plus or minus, increasing or decreasing volume is sharing the image speech recognition. If you see your example, y is equal to x square, I have a set A minus 1, 0, 1, set B 0, 1. Minus 1 is also going to 1, 1 is also going to 1. So what is happening? Minus 1 and 1 is sharing the image 1 over here. So this is many to one function. See this blue diagram and a green diagram. Codomain are the same for both the things 0, 1, 0, 1. Here domain is different. Minus 1, 0, 1 and here 0, 1. And the functions are the same. Both are using the same thing, x square. But if you look at the blue diagram, minus 1 and 1 is sharing the image 1 and the green diagram doesn't share the image. So what we can understand, this is the blue diagram is an example of a many to one function, and a green diagram is an example of a one to one function. We can just understand from this, one to one function depends on domain. Let's go to the next, onto function. So what is an onto function? If my range is equal to codomain, I will call that as an onto function. So here you see here example, my codomain is what? 1, 2, 3. What is my range here? A is mapped to 1, so 1 is also an image, 2 is an image, 3 is an image. So here range set and a codomain set is the same. In other words, to understand in a better way, all the elements in the codomain should have a pre-image, or they should be mapped from the domain set, and that is my onto function. If you remember the ICU example, my patients P1, P2, they are the codomain set. Monitor M1, M2, that is my domain set. What did we say? Every patient should have what? Monitor. So here P1 should also have an image, P2 should also have an pre-image. Pre-image. They should have a pre-image. So this is an need of onto function. So the same example, like same function, I'm using x square over here. My domain set is 0, 1. My codomain set is 0, 1. 0 is mapping to 0, 1 is mapping to 1. Here you can see my codomain. Every element in codomain has an image. So therefore this is, pre-image. So therefore it is an onto function. So what is an into function? Opposite of an onto function. That is, at least one element should be there in a codomain which doesn't have a what? Pre-image in A, or any one element should exist in B that is not mapped to the element of A. So let's see, this is an example given over here. If you see here, 4 here doesn't have any pre-image in the A, or 4 is not mapped at all. So therefore this is an into function. This is an into function. Bijective function is nothing. If it is both 1, 1 and onto, then we call that as an bijective function. Let's understand through the diagram over here. First we have to check what it is, 1, 1 or not. A is going to Z, B is going to X, C is going to Y. Here no image sharing is happening, so therefore this is 1, 1. What is onto? Every element in B should have a mapping from A. Here X, Y, Z all are mapped, so therefore this is onto. When my function is both 1, 1 and onto, I call that as a bijective function. Okay. So we are going to learn how to use a graphs. So what can all we can, from a graph, what we can know about function? We can first check whether it is a function or not, and the second thing we can check whether it is an one-to-one function or not. To check whether a function or not, we will use a vertical line test. For one function, we will use an horizontal line test. Let us understand it now. See here, vertical line test. What I do, I have a graph. I will put vertical line in that graph. I will draw vertical lines. And if that vertical line just touches one time in a graph, then it is a function. If it touches 2 or more than 2 times, it is not a function. Why it is like that? For every input, what I should have? Only unique output. You see here, y is equal to x graph, where the blue line here cuts exactly once. What we understand from this, it is cutting only once. So therefore it is a function. Come here. There is x square plus y square is equal to 9. You can see that line is cutting in 2 places. That means x is having what? For one value we have a 2 functional values. So therefore it is what? It's not a function. Horizontal line test. What do we do from horizontal line test? It is done to check whether it is one function or not. See, we will draw an horizontal line and we will check whether what is happening, whether the graph is cutting in one place or whether it is cutting more than once. If it is cutting more than once, it is not an one function. Why it is not one function when it is cutting more than once? When we draw a horizontal line, what it means, for one y value, There is, if it is cutting more than twice here, see here in the red diagram, for one y value there are what, 2x are mapping to one y value. You can see here this point and this point is mapping to the same y value, that is image sharing is happening. So therefore it is not 1 1 function. Quickly let us recap. 1 1 function is what? No image should be shared. Many to one function means image should be shared or image sharing will happen. On to means my range should be equal to codomain. Into means my range is not equal to codomain. Bijective means 1 1 plus on to. Vertical line test is done for a function. Whether it's function or not, we are going to check it. If it cuts only once, then it is a function. Horizontal line test, my horizontal line cuts only once the graph, then it is an 1 to 1 function. So you can pause this here and you can do these sums and then you can continue the video. So let us end with application. So why do we need functions in mathematics, or why do we need to learn types of functions in mathematics? First thing, economics. So to find the cost or a profit, that is represented as a function. Then in physics, my projectile motions, that is missiles that are used in defense or an electrical circuit, all are functions. Medicines, ECGs are a sign functions. So even ECGs, drug dosage, all those are calculated using functions. Weather forecast are done using functions. So if you GPS, without GPS, that is Google Maps, Swiggy, Zomato, nothing is possible. Those for GPS navigation also uses functions. So you can understand that we need what, functions to solve the problems in real life. And different scenarios, as I told in the previous thing, if you remember, the TV remote, ICU, ID card, the seating arrangements, all this is what, an example of a real life scenario which demands different types of functions. If you understand about the seating scenario in a depth manner, what, like to avoid cheating, we are giving unique places to them. It is like what, 1 to 1 function. We are, as a family, we are sitting in a dinner, that is many to one function. So different scenarios demands different choices. So therefore it is essential for us to have a knowledge about the types of functions. So these are the answers for the assessment which is given previously. Also, there is one quizzes link. You can scan this QR to, there are some 7 to 10 questions are given in the quiz. You can just try those and you can check how much you have understood it. For more references, you can check the grade 10 Samachir Kalvi Tamil Nadu book, and CBSE grade 11 and grade 12 also has about the functions and types of functions. Thank you.